Welcome to the Droidcon Italy webinar. My name is Francesco Brocero. I am one of the organizers of Droidcon Italy. Today you'll be reading about Sebastiano Poggi from Sebastiano Poggi on Ktor. It is Sebastiano.
Hello.
Ktor to your Hertz content. Easy mobile backends in Kotlin. We'll be using YouTube comments for Q&A. Please post your question there. This webinar is brought to you by Synesthesia and powered by Amazon Amplify. Thank you, Sebastiano. Have a great webinar.
Thank you very much. Cool. So hello, everyone. I am Sebastiano, and today we're going to be talking about mobile backends. Now, most of us here are mobile engineers, and our world is generally limited to this, a single device, generally a phone, sometimes a tablet, sometimes something else, but most likely a phone. That is great, but as we all know, an app that only lives on the phone and doesn't talk to the outside world has somewhat limited utility. So in real life, we often also talk to a backend of some sort. Now, for what concerns mobile apps, these interactions are generally fairly straightforward. They take the form of maybe the user interacting with your app. The app needs to get some data. It sends a request to the backend. The backend does the bleepity bloop stuff and sends back a response. And in return, we can do something like showing a notification or maybe telling something to the user, displaying more items, and so on and so forth. But mobile engineers generally don't work on the backend. Like all this stuff of all this picture, they only look at what's on the app side. Generally, if you're lucky enough to work at a company where the backend is handled by a backend team, well, you just talk to them, ask them nicely, and maybe they do what you need. If you're in a startup or a company that has more vertical structure, then maybe you are the one doing the backend. If you're the one doing the backend, then probably this talk is fairly less useful to you, but maybe interesting anyway, because you possibly don't know about Ktor, and maybe you're using JavaScript or something else on the backend. But in any case, we are going to be focusing today on the backend. At some point in time, you will have worked with an API on some server located somewhere. There's, I would say, as a mobile engineer, especially as an Android engineer, there's three main kinds of backends that you will have to deal with. Most likely, you will have touched REST backend. Maybe you work in a company that uses GraphQL, or maybe you work at a company that uses GRPC or some other form of remote procedure code. If you're in a startup or if you're working on your own pet project, maybe you've used something like Firebase or Firebase Firestore or real-time database, all those things, the so-called platform as a service. But today, we are not going to be looking at things like Firebase. On the other hand, what we want to be able to do by the end of this talk is to be able to create our own backend for our own project and app. For example, this is particularly useful if you have, say, a pet project that you need a backend for. You don't need to go and find someone else to do that for you. You can pretty much do it by yourself. That's what we're going to be looking at today. Now, possibly many of you already know what I'm going to be saying, but I feel like I need to do a brief introduction about these three words that you see on screen right now, because for as much as you're likely to have at least heard of them, maybe you don't really know what they are and what those things actually mean. So we're going to be starting with REST. What is REST? Well, REST is the oldest and simplest way to make backends, to have an API, and that is also the simplest one conceptually to understand. Pretty much everyone will have touched the REST API at some point in their development career. And even if they haven't yet, they will at some point. It's inevitable. REST is more of a style of doing things rather than a proper protocol. And it is not a standard in and by itself. There is no hard-coded RFC that says this is REST, this is what it means. But the generally accepted definition of REST in the world uses a lot of open source and standards in the actual stack. There are two basic concepts to REST. The first concept is methods, and the second concept is resources. Now, methods are, you've probably done an HTTP request at some point in your life, and you will have done a GET request, or maybe a POST request, maybe a PUT, maybe delete. Those are the so-called HTTP methods. And methods in REST are actions. So you're telling the server, I want to do this. And obviously, like every action, they need an object on which they are performed to. And these are the resources. So in REST, everything is a resource. Every URL maps to a specific resource or a set of resources. And then combining methods and resources, you can, for example, say, get me this resource, or delete this resource, or add this new resource there, or update that resource. So that's the basic idea behind REST. It is, of the three things we're seeing today, the most widely used by far. And by virtue of its wide availability and the fact that it's simple and it's old, doesn't mean it's bad. It's just a very widespread standard you can use pretty much on anything. That's REST. Now, what is GraphQL? GraphQL is an API language that was created by Facebook. It is very much not a standard, just as much as REST, but it has a strict open source specification that was put together by Facebook back then, and has been evolving over time, has been adopted by the community. It is served over HTTP, just as much as REST usually is. And the main difference with REST is that instead of having multiple endpoints for multiple things, and the idea is that you have one single endpoint, and then you use a query language to tell the server, okay, I need this, this, and that in this specific form. Whereas with REST, the server decides what representations are available of the data, and the client maybe needs to get stuff from different places and put them together by itself. GRPC, and in general, RPC, stands for Remote Procedure Call. GRPC is a specific way of doing Remote Procedure Call. It's a protocol that was created by Google. Again, it is not a standard, but it does have an open source specification. So in that sense, it's very similar to GraphQL. It is served over HTTP 2 exclusively, if I recall correctly, and it is based on protocol buffers. Now, REST and GraphQL generally use text-based representations. With REST, at least you can use whatever you want. You can even use proto-buffers if you want, but generally you will see something like JSON being used. And the same goes for GraphQL. Generally, payloads are represented using JSON. In this case, instead, they use protocol buffers. Now, protocol buffers are a binary format, so they're much more efficient on the wire. They take less time because they're smaller. The downside, obviously, is that you cannot just dump the response and see, oh, this is the data I'm getting. You need to deserialize them. So it's a bit more complicated. But on the plus side, what this gives us is the ability to generate type-safe client and server bindings. So basically what you do with gRPC is you define the protocol buffers, the protocols, which are, think of them as the data classes. They're the same thing. They're defining their own language, which looks a lot like Java. And then the protocol buffer can generate actual classes for you that you can use, and then GRPC can actually generate the whole bindings, so it takes care of the whole thing for you. Okay, so we have seen 3 different ways of doing backends. Which one is the best for you? Well, it depends. It really depends what you need to do, what your company is using, what your clients maybe are supporting, and so on and so forth. Today, we're going to be looking at REST. The reasons are fairly obvious. Is the most well-known one. It's the one that works everywhere with everything. And it's also the one that is fully supported by Ktor. You don't need to do anything to support RESTful APIs in Ktor. It works out of the box. Now, there's one note I want to do before we get into the meat of it. There is varying spectrum. There's a spectrum of RESTful. As I said, it's not a very strict definition. So you can go from extremely specifically adhering to the RESTful definition to RESTful enough. And the GitHub API is on this side of the spectrum. Our API will be more on this side of the spectrum. It's just to give you an idea. Obviously, you can absolutely implement a properly, fully RESTful API with Ktor. It's just outside of the scope of this talk. Okay, I keep mentioning Ktor, but what is Ktor exactly? Well, Ktor is a Kotlin-based framework that allows us to create asynchronous clients and servers that communicate over the network. The main advantage of Ktor for Android developers is that we know Kotlin. Possibly, probably, we also know at least what coroutines are. And that's going to make it much easier for us to use, because obviously, it's at least when it comes to servers, but when it comes to clients as well, given we're talking about network stuff, asynchronicity is key. And Ktor is built around the idea of being asynchronous. And it's using coroutines to make asynchronicity easy. You don't need to create your own custom executor-based thing. Don't do that. You don't need to anyway. Ktor, anyway, is unopinionated, apart from the fact that it uses coroutines, in the sense that it allows you to pick the pieces and the features that you need and that you like, and only use those ones. So you will not, by default, have a giant monolithic thing that brings in tons of things you don't need. You just pick the ones you need. And on top of that, it's made from the ground up to be testable, which means you can write unit tests besides integration tests as usual, but you can also easily write unit tests for your code, which is very useful, and is not that easy in all cases with other frameworks. In any case, if you want to learn more about it, you can go to ktor.io. There's a lot of documentation there. More is coming, as always. Why is Ktor something different from other web frameworks? Well, first of all, something that is fairly uncommon. It covers both the server side and the client side. And it is unopinionated, so there's a lot of flexibility in how you implement each one. It supports Kotlin multi-platform on the client side, which is very interesting, because that means if you're writing a Kotlin multi-platform project, then you can use Ktor across the whole thing on the backend and on all the clients that you have. It also supports REST, as I said, but it also supports WebSockets, which is fairly useful when you want to have real-time communication of some sort. So that's another thing that Ktor does for you. And there's support for authentication, both built-in HTTP basic authentication, so username, password, but also token-based. So for example, OAuth. It's very easy to implement authentication using a Google account, for example. It's just a few lines of code. In our case, we are going to be creating an example RESTful server that has some REST APIs that serve JSON responses. And it also has an HTML endpoint, because I want to show you how easy it is with Ktor to also create an HTML web service. So you can run your own website on top of it. It's super easy. And we're also going to see a simple example of authentication. We have one goal for today, which is doing something that runs locally on our development machine and also can be easily deployed on Google Application Engine. So App Engine is basically a virtual server that you can run on Google Cloud. And we want to be able to deploy on that. And we're going to be doing that by the end of today. It's very easy. To make this talk a bit more grounded in reality, I've made up an example project, which is called PushBeat. It is a fictional IoT service that would have maybe an Android companion app, maybe iOS as well, if you use Kotlin multi-platform. The idea behind it is that the scenario is that you track your heartbeat with using some heartbeat sensor, maybe your smartwatch, maybe something like that. And when you push code, the service will tell your Git client, hey, actually, your heartbeat is too high. And if it's too high, maybe you should take a break. It's like, think about it. Maybe you're just rushing through your code. It's not great. Now, this is a silly, completely made up example idea. The code for the server side, though, does exist, and it's on GitHub. Don't expect it to be fully featured or anything. It's just to show you the things we're going through in a more realistic scenario, for as much as the idea is not really realistic. Now, we need to begin by setting up our App Engine SDK on our computer. If you have done it already, if you have already worked with GCP, it's something you don't need to do again. But if you haven't, you just need to install the Google Cloud SDK. It's very easy. If you're on a Mac or on Linux, I think, that's the command you need to run. I think if you're on Windows, you need to download the installer from the Google Cloud SDK website. I don't remember for sure. I don't generally use Windows for development, but you'll find out. Once you're done with that, you go on the Google Cloud Console, which is on console.cloud.google.com. You click the project picker down there, and then it pops up this dialog. You click new project, you follow the instruction, you set up the name of your project, and that's it. You need to remember to enable billing. So you need to put credit card information there, and you need to enable App Engine because we will need to use it. You can do that all from the console. It's very easy and fairly well documented. Next up, going back to our console, you need to install the App Engine Java SDK component. Again, it's a simple command. You just run that. Next up, you log in with your Google account to GCP. That's so that the cloud SDK knows what projects you have and can push stuff. That's a fairly easy thing. It opens a page on the browser. You log in normally, allow access, and you're done. And then you select the project that you have used. In this case, we assume that you have already created or at least cloned the repository for PushBeat or whatever project you're working in. You go into that folder and you run gcloud init, follow the instructions. That's all you need to do. Cool. So the App Engine SDK setup is now done. We need to put up our build script. And by that, I mean, I'm going to be using the Kotlin Gradle script. The same pretty much goes for the Groovy script, if you prefer that. I'm just going to go with Kotlin because I prefer it. The first thing we need to do is we need to add the war plugin. That's the plugin that will generate the servlet that is going to be run. The servlet is the Java web application thingy container. I'm going to be very vague and hand-wavy because I don't want to go too in-depth into those things today. Next up, we want to have the App Engine Gradle plugin in our build. To be able to do that, we need to make sure that we have Maven Central in our build script repositories because, unfortunately, the plugin is not available on the Gradle plugins portal because they chose not to. Next up, just add the plugin. We do it the old-fashioned way because if we do it with the plugins closure, unfortunately, especially with the Kotlin Gradle DSL, there are some problems. There's a bug that makes the build not work because there's some timing assumptions that are fairly broken, at least as of the version you see on screen, 2.2.0. Hopefully, they're going to fix it in the future. Last thing is applying the plugin. You put it in the class path. Now you apply it like any other Gradle plugin. Cool. Now we need to configure it. Configuration, you can configure a bunch of things, but in our case, we're going to stick to the minimum. Now, it looks fairly ugly on the Kotlin DSL. In the Groovy DSL, it's a bit better. You just have the app engine closure. The rest, the contents are the same. But just FYI, that's the difference. It's not documented on the plugin website, but I'm telling you. We need to specify the project ID and the version. We're using these two specific values because the plugin knows that when it sees those values, it will go and get those values from the configuration you defined in the Google Cloud SDK a second ago when we did Google gcloud init. Again, you can follow the instructions on how to install the SDK there, and it will also explain this stuff a bit better. I'm just going to cruise through it. Next up, we need to make sure that we have the Ktor repository defined in our build. It is not available on Maven Central, so we need to define the specific dependency repository there, so Gradle knows where to get it. Next up, we define the actual Ktor dependencies. There's a bunch of them, as you can see. That's because Ktor, as I mentioned, is very modular and very pluggable and has the concept of features that we're going to go at. We're going to look at a bit more in detail in a second. But the idea is that those 4 things that we see here are features. For example, the HTML builder that we will use to return HTML, the authentication, we have locations, another thing we're going to see in a second. And then we have serialization. Now, serialization is used for to be able to return responses in JSON, in this case, using the Kotlin X serialization library. Next up, we need to have a provided compile dependency on the app engine itself. Why is it provided compile? Well, obviously, if you run it on app engine, that will be on the class path. The app engine will put it on the class path for you. When you run it locally, the Gradle plugin for app engine will make sure that that's actually there on the class path. So you don't use implementation here, you use provided compile. Cool. Then we have Kotlin X serialization. We need the runtime. We also have the plugin set up, but that's outside of the scope of this talk. And then we have logback. Logback is our logging backend that we use. Good. We're almost there with the configuration. There's a couple more things that we need to take care of. First of all, we need to define a couple of files in our application resources. They're similar. The application Java resources, they work the same way as the Android resources, but they are in the main/resources folder. First up, we have application.conf. That's the Ktor main configuration. We're going to see some more of it in a second. Then we have logback.xml. Logback is the logging library, and this is the configuration for that logging library. In this specific case, it's a fairly standard configuration, but we have one extra thing. We have 2 appenders. The appenders are the outputs to which the log goes to. One is standard out, because obviously we want to be able to see what we log in the console when we run the application. And the other one is cloud, because when we run on the cloud, we want to send the logs to the GCP logging service so that we can see it on the GCP console. Next up, we have a few items in the web app/webinf folder. First one is app engine web.xml. This is the app engine configuration. It tells app engine what we want to run. The next one is login.properties that is used by the GCP logging to know the configuration for logging. In this case, it only tells it to log things that are at the info level and higher, because you don't want to spam the log. Last up, we have the web.xml, which is the servlet configuration. So as I said, servlet is the container that runs our application. So for us, the flow goes like this. App Engine looks into the App Engine web.xml file. The app engine.web file says, I need to run a servlet. So the app engine then goes to web.xml and it says, okay, this is the servlet configuration. I'm going to spin up the servlet. The servlet configuration is going to look into the application.conf file that will tell it what to run exactly. So starting up the server, how exactly does it work? How do we say to Ktor what to run? Well, if we look in the application.conf, you can see we have defined the port that this runs on, which is 8080, or if defined elsewhere in the environment, then that one. And we define the full qualified path of a function, a Kotlin function, that is our startup point. So you can see in application.kt file in the repository, there is a function that is called module that is an extension of application, which is a Ktor class. You will notice that the fully qualified name completely matches. Obviously, otherwise it will not work. And then that's all you need to do to tell Ktor where to start and to make it work when you deploy remotely as well. Now, a couple of minutes ago, I mentioned features. What are features? Well, Ktor, and I stress this point, has a very modular design. Everything in Ktor is expressed as a feature. And features are the way that Ktor is able to be modular. Features are then integrated interact with the pluggable pipeline that Ktor has. Basically, when Ktor gets a request, there's a whole pipeline that it goes through. And each feature can interact with various stages in that pipeline and even inject its own stages. And you can think of them as sort of HTTP interceptor, but on steroids. You can do much more than that. But intuitively, it's the same idea. Everything in Ktor is a feature. Everything. From routing to authentication to content negotiation, everything. And as I mentioned earlier, it's very useful because you can only install the things that you need when you need them. So you don't have a giant server that has 1,000 dependencies that you don't really use, but they're all built in because your framework is monolithic. That's not the case here. So looking at our application.module function, we have a few things defined here. As we saw, we have the authentication feature installed as a dependency. Now, how you actually enable things in Ktor, there's a DSL, which is to install a certain feature. Now, here you can see we installed the authentication. The authentication we support in this case is the basic HTTP authentication that takes a username and a password. In this case, they're hard-coded. Obviously, this is a sample project. Do not do this in production. I hope nobody ever thought that was a good idea. It is not a good idea. I'm just doing it for simplicity's sake here in this case. Now, next up, we have locations. Now, we're going to be talking about locations later, so let's just skip that for now. Next, we install the compression feature that tells Ktor that you are supporting compression in requests, so you can respond with responses payloads that are compressed. In this case, I say you can use gzip and you can use deflate, and you can put some restrictions around when one is supported and one isn't. For example, you can see it for deflate there. It's all you need to do to support compression in your responses, and it's always a good idea to have it. So please do it. You can also have features like default headers that allow you to inject headers in all the responses. In this case, we only have one, and it's more for demonstration's sake than anything, but it might be useful for you. For example, you can say this is the version that I'm running. It's useful when you debug, for example. Next up, you can see JSON. We are installing content negotiation. JSON is an instance of the Kotlin X serialization JSON class that we create using some specific parameters here. And all we need to do to have Ktor automatically use it to serialize and deserialize JSON to and from text string to the corresponding classes is to install the JSON feature. That's it. That's all you need to do. We're not going to be using it much in this demonstration, but it's fairly useful when you actually want to use content negotiations to its fullest, which means you can support on a single endpoint a variety of MIME types for content types. And the idea is that you have one single pipeline that elaborates the result. It creates a data class or whatever that can be serialized. And then Ktor, depending on the selected content type, will pick the right converter for you. So say if you want to return JSON, then it picks the JSON converter and converts the class to JSON. If you want to pick something like XML, there's that, and so on and so forth. You can use protobuffer, whatever you want. You just need to write a converter for those. Cool. Now, logging is not particularly interesting. It's just something that we log. One thing to say, I have set logging to info. Don't do it in production. Just too noisy. You want logs to be at the debug or maybe trace level. Anything underneath the normal logging you have in production. Now, status pages are another interesting feature. Status pages are the same thing you think of when you are browsing an internet website and you go to a URL that doesn't exist and you get a 404 page. That's a status page. That's the same concept you have in Ktor when, for example, there is something returning a not found somewhere in your handling code, then this will intercept whatever you're returning and return something else. And you can see you can do it for exceptions as well. There's both authentication and authorization exceptions there, which are built into the authorization Ktor feature. But also we have defined a high-level intercept any error and return a 500 kind of status page there as well. Last thing is routing. Now, routing is its own, and it's a very crucial topic. So we're going to be looking at it separately from the concrete example first. Now, in Ktor, this is how you define, I want to respond to GET requests on the root URL. That's it. Inside of the closure, you define your handler, you do stuff, and that's it. And the same goes for other methods. You can have post, you can have put, you can have delete. You can structure things in different ways in Ktor, and it's fairly intuitive what to do when at least when it comes to specific handlers, like in this case. But you can also have static resources. For example, you can have a 404 page that it comes from, in this case, from a resource. So when someone is trying to get something inside of static and it's not there, then you turn a 404 page. One last thing, if you are in trouble debugging routing, you don't understand why something is picking a certain route instead of something else, then you can use trace. It's very easy that you add that one line of code, and every time you do something, you get a request, and Ktor will output the full decision tree that is following, so you can understand what's going on. Remember that routes are sorted top-down, so if two routes of the same quality match at the same level, the first one will be picked and not the second one. Now, how do we actually handle those requests? Well, for example, if we want to respond with HTML, we can use the HTML DSL feature, that kotlinx.html. The support in Ktor is done through the dependency that we added to the project that I shown you earlier. If you do this and you run the project locally with the app engine run Gradle task, then that's what you do. You just navigate to the root and you get the response. And now I'll show you to deploy this to App Engine. The one thing you need to do is run the App Engine deploy task, and that's that. That's how simple it is. That's all it takes. You just run that task. Your application is then live on GCP, and everyone can access it. Super easy. Now, when we need to respond something else, for example, we want to respond with some JSON. In this case, obviously, it's hard-coded. In real life, you would be composing a data class and serializing it and returning it, you can use respond text if you want to respond some text. You can say this text is actually JSON, or you can say it's HTML, or it's plain text, whatever. You can specify any content type. In this case, you see we just say return this JSON and use the built-in IntelliJ HTTP client. I think it's only on Ultimate. I'm not sure it's on Community Edition, but you can use any HTTP client, obviously, to do this. And you can see that the server responds with the JSON as expected. What if you need to have IDs or parameters, like query parameters? Well, Ktor supports that fairly intuitively. You can have query parameters. You can get them by just using the RESTful parameters API. And you can get parameters inside of the URL by just defining them with curly braces. And then you can access them by name. So in this case, for example, we expect there to be an ID parameter in the URL, and we expect a name query parameter in the request. So when that happens, for example, we run this request where the ID is banana and the name is Luke. And you can see there's that. We have it in the request, in the response, as expected. Now, how is routing in PushBeat defined? Well, it's fairly easy given what we have already seen. We have our API endpoints and the route that responds on the route. Sound the same. The first one is the HTML page where we will provide a user-facing representation of the data, and the other ones are the proper APIs. Maybe you want a /API/something path to distinguish them better, but it doesn't really matter. You can have anything. Now, in this case, let's look at the render registered beats, because that responds with a fairly more complex page than we had before. Now, using the HTML DSL, it's super easy and super intuitive to return, to create the HTML response. It's much better than using a string builder and attaching bits and pieces or using string interpolation. In this case, we say there's a head section in the HTML. It contains a title, a CSS, a JavaScript file, links to them. We have a body that contains title and subtitle, and it contains a list of items that we have registered, because you might, for example, have multiple heartbeat providers. In this case, this is code. So we can simply say if the source is empty, then we just show an empty state, very simple one in this case. But if we have sources that are registered, then we can actually render the contents of those sources. We can even provide a link to refresh the data, to do stuff. It's very easy. So that's it. That's all you need to do to render a HTML page. One thing, going back to the static resources, in this case, you will notice in the HTML, I was referencing a CSS file and a JavaScript file. They are defined here in the static block. So just FYI, that's how you get them. And they are, in this case, resources. You can also get files from the file system, but it's easy if they don't change often to just dump them in the resources. That makes it easier to retrieve them. Cool. So we have this, the locations are defined as strings, but we can do better than this because this is not very well typed, and this is Kotlin, and this is something we can do. We can actually have types, so we don't have to copy paste the strings. We don't have to have IDs matching with things. It's like, that's not great. We are doing better using locations. Now, locations are simply classes that are marked with the @location annotation. In the @location annotation, you define the path that they have. They work the same way as they worked with the explicit path in the routing. The cool thing about locations is that they allow you to have strong typing, and they allow you to have nesting in a more familiar way. And they will make your life easier when you actually respond to requests, because you don't need to go fishing for the parameters. That Ktor will pre-populate all the variables for you. So for example, in this case, you can see we take the ID of a bit location. So a bit location is defined by having an ID property that is matching the ID placeholder in the path. And with that, we can just access it in our handler as it is the current location, and thus it will be populated. It will be an instance populated with all the values that we need. Even more so, for a nested location, you can access parameters that are defined in the parent, because in this case, for example, the refresh location, which is a child of bit location, as you can see, it defines the parent bit location as a parameter. Ktor will populate that for us, so we can have access to the ID of the parent inside of the child location. You still need to register them at the same level as the parents, but when it comes to handling them, it's much easier and more intuitive. Cool. Last thing on our menu today is authentication. This is how you implement authentication in Ktor. We have defined an authenticator earlier, and this is how you say this handlers, these routes, require users to be authenticated with this specific authenticator. That's it. That's all you need to do. And once you have done that, you can see that if you just do the request without passing any authentication headers, you will get, as expected, an unauthorized response that says, well, sucks to be you. But if you do have the authentication header, in this case, you will remember we have a basic HTTP username and password, which are hard-coded PushBeat. Then you run the request again, and ta-da, you get the actual content. Cool. That was it. Now it is the time to look at questions. If there is any questions on the streaming, let's see.
Thank you, Sebastiano. Sebastiano will be taking questions shortly. I'd like to once again thank our sponsor, Amazon Amplify, and let you know that our next webinar will be Tuesday, 7 July at 11 o'clock. Hope to see you there. Back to you, Sebastiano, for questions.
Thank you. Doesn't seem to be any questions on the live chat on YouTube. I'll give people maybe a couple of minutes, and if there is none, you can still reach me on Twitter if you want. And okay, so Kennedy was asking, where can we download the sample? It is on my GitHub. I will tweet the link to it in a couple of minutes after I'm done with this. And I will also tweet the link to the slides, which also contains the link to the repository. I have uploaded them already, but in the meantime, thank you. You can find the slides in a couple of minutes. I still have to publish them, but they are there. They're going to be at this URL. Again, I'm going to be tweeting the link, so don't go crazy. You don't need to write it down now. Is there any other question? Doesn't look like it. I'm still going to give a minute for people. Oh, yeah, there's another one that I hadn't seen. How to do GraphQL with Ktor. I do not know. It might be possible, but I have never used GraphQL myself, so I haven't really looked into it. There might be a way to do it, but I don't know. I would imagine if you define the endpoint in Ktor, then the whole GraphQL thing will be done by the GraphQL server anyway, so you would mostly be deferring to it. Ktor doesn't really do GraphQL because it's a thing on top of your actual web service. Ktor mostly handles being a web service, so it exposes endpoints. So it will expose the endpoint for you, probably, but then you need to call to send the data that you get to your GraphQL setup, whatever that is, and then return a response for the clients. I think that's the scope in which Ktor actually enters the picture. I think that would be it. There's no other questions that I can see. So thank you, everyone. I hope you had a good time and you learned something today.